Good morning, class. Today we are working on lesson 4.4 out of your GoMath textbook, and you will need page 209 for this lesson. So if you don't have that torn out yet, please go grab it. All right. Today is day one of learning about the distributive property. We're going to spend 3 days practicing this. Okay. It may seem complicated at first. I promise you it's not. Just listen and follow along carefully, and you will be ready to do it on your own in no time. So, distributive property. Essential question, how can you use the distributive property to find products? Remember, the product is the answer to a multiplication problem. So, distributive property is going to help us solve the more difficult multiplication problems since we don't have all of our facts memorized yet. All right, here we go. Let's unlock the problem. Mark bought 6 new fish for his aquarium. He paid $7 for each fish. How much money did he spend in all? Okay, so that means we're going to find 6 times $7. It says describe the groups in this problem. Well, I have 6 groups of $7. And you remember, groups of is where your multiplication symbol goes. We can use the distributive property to solve this problem. Here's your definition. The distributive property states that multiplying a sum by a number is the same as multiplying each add-in by the number and then adding the products. And that probably makes no sense to you right now, and that's fine. But hopefully it does by the end of this lesson. I want you to remember that the sum is the answer to an addition problem, and the add-ins are the numbers being added. Okay? So what we're going to do is we're going to take one of the numbers from the multiplication problem, which would be one of the factors, and we're going to break it into 2 add-ins. That's 2 numbers that would add up to equal that to create more simpler problems. All right, let's start by practicing with arrays. It says make an array of tiles to show 6 rows of 7. So let's check this. 1, 2, 3, 4, 5, 6. So I've got 6 rows here. 1, 2, 3, 4, 5, 6, 7. I have 7 rows here. 6 rows of 7, which represents 6 times 7. Now, I don't know 6 times 7. I don't want to sit here and count all these squares up. So I'm going to use distributive property to solve this in a more simpler way. So this probably looks really complicated to you. Just watch and follow along. 6 times 7. Well, 7 is not a very friendly number. So what are 2 numbers that add up to equal 7 that are really easy to skip count with? 5 and 2. So we're going to break 7 apart into 5 plus 2. So now our problem reads 6 times 5 plus 2. Because 5 plus 2 is the same as 7, right? Okay. So now I'm going to distribute. All right, I'm going to share the 6 with the 5 and with the 2. So we're saying that 6 times 7 is the same as saying 6 times 5 plus 6 times 2. So I'm taking my big problem and I'm breaking them into 2 smaller ones. Now I want to show you this on this array. This is the same array over here. The difference is we've taken our marker and we have made a line to separate this into 2 smaller arrays. If you separate into 2 smaller arrays, you're still using the same number of counters, but you're going to make it more simple to solve. So you know that you can solve for each array, then add them back together to find the total of the original array. Same thing that we're doing down here. So now instead of having 6 rows of 7, I have 6 rows of 5 plus 6 rows of 2. Okay, Same array, they just drew a line here. Okay? So I know 6 rows of 5 is 6 times 5, which is where that came from. And 6 rows of 2 is 6 times 2. There's that. And look up here. 5 plus 2. That's the same as 7, right? Isn't that what we wrote right here? Okay. So this picture is showing you where these numbers are coming from. So now let's solve for each array. So the first array is 6 times 5. Well, 6 times 5, 5 is an easy number to skip count with. So I can say 5, 10, 15, 20, 25, 30. So I know 6 times 5 is 30. So I'm going to write the answer right underneath it, 30. Then I'm going to solve for this side of the array, which is 6 rows of 2, or 6 times 2. And I know that I could skip count by 2's, but I also know that times 2 means that I am just doing a double of 6, and 6 plus 6 is 12. Okay, so I know this array totals to 30, this array totals to 12. Now let's put them back together to find out what they total as one big array. 30 plus 12, well, 30 plus 10 is 40, and 2 more is 42. So now I can go back to my original problem, and I know that 6 times 7 equals 42. I broke apart my array into 2 smaller arrays, solved for each of those, then I put the totals back together to find the total of the large array. Now, I'm not finished because this is 6 times $7. So Mark spent $42 for his new fish. Okay, let's keep going. Suppose Mark bought 9 fish for $6 each. You can break apart a 9 times 6 array into 2 smaller arrays for facts you know. One way is to think of 9 as 5 and 4. Draw a line to show this way, then find the product. So, let's check this out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 rows of 1, 2, 3, 4, 5, 6. 9 rows of 6, right? But it wants me to break apart the 9 because it's the bigger number. It's the least friendly, right? Yes. So if I'm going to break apart the 9, that means I need to chop it across into 2 smaller arrays. And they suggested 5 and 4. 5 we can skip count with quite easily. And 4s you learned in lesson 1 by doing 2's and then doubling that. So let's make it 5 and 4. So that means I'm going to have 1, 2, 3, 4, 5. Draw my line. So now I have 2 arrays. To make it clear, I'm going to change colors. So now instead of 9 rows of 6, I now have 1, 2, 3, 4, 5 rows of 6 and 4, 1, 2, 3, 4 rows of 6. So now you can see I have 2 new arrays that I made from the big one. And this one is 5 rows of 6, or 5 times 6. And this one is 4 rows of 6, or 4 times 6. So we're going to solve for these smaller arrays, and then we're going to add them back together to find our big array. So now I'm going to write this out over here to show you what it would look like. So instead of doing 9 times 6, we're going to do 5 times 6 plus 4 times 6. Because 5 and 4 total 9. Remember, we did that right here. 5 plus 4 totals 9. So now we're going to solve for each parentheses, which is each array. 5 times 6. So let's solve for this array. Okay? We just did this number, but we're going to do it anyway. We can skip count by 5s. 5, 10, 15, 20, 25, 30. So 5 times 6 is 30. And now we need to solve for 4 times 6. Well, you learned in lesson 1 that half of 4 is 2. So what is 2 times 6? 2 times 6 is 12. And what is 12 doubled? Well, 12 plus 12 is 24. So 4 times 6 is 24. So now we want to add these up to put our array back together to show how much it is together as one large array. So 30 plus 24, well, 30 plus 20 is 50, plus 4 more is 54. So Mark spent $54 for 9 fish. All right, let's do another one. Draw a line to show how you could break apart this 6 times 8 array into 2 smaller arrays for facts you know. All right. There are usual multiple ways that you can break apart these arrays. And like they just said, you have to kind of pick the numbers that you know that you're best at. So what numbers are we multiplying? Well, 6 and 8. This is 1, 2, 3, 4, 5, 6, right? And this is 1, 2, 3, 4, 5, 6, 7, 8. This is 8 up here. Okay, so I have 6 rows of 8. Boom. We want to break it into 2 smaller arrays. Well, 8's the big number, so let's break that number apart. What 2 add-ins would go into 8? Well, 2 plus 6 is 8, but 6 isn't really a friendly number that you can skip count easily with. 5 plus 3 is 8. 5 is a good number for skip counting, but 3, some people have a hard time with 3s. What about 4 plus 4? So if you did 4 plus 4, then you would actually only have to solve one array and double it because they would be the same, correct? So if you have a number you can do doubles on, a lot of my kids like to do doubles because it's easier. You only have to solve for one array and double it. So let's chop this in half so that we now have 6 rows of 4, no longer 8, plus 6 rows of 4. Notice that I take the time to label each array. Okay, now that I've broken it into 2 arrays, I need to remind myself that these are 2 separate arrays now, and I'm going to label each one as such. So what numbers am I going to multiply? Well, for the first array, it's 6 rows of 4, so 6 and 4. For the second array, it's 6 rows of 4, so 6 and 4. See what I mean? We're going to have the same problem twice, so we only have to skip count to find our answer once. What numbers are we going to add? Well, we don't know yet, right? Because we have to solve. We have to figure out what's 6 times 4. We actually did 4 times 6 up here. And the commutative property says that it would have the same answer. So what was 4 times 6? 24. Because 2 times 6 is 12, and 12 plus 12 is 24. So that means we're going to be adding these totals. So this array totals to 24, and this array totals to 24. Remember, we're adding. So we're going to add 24 plus 24. Okay? So everything we just did here and here, let's break it down into showing all of our steps. Okay? So we started with 6 times 8, and we broke this 8 apart into 2 add-ins. What 2 add-ins were those? The 2 numbers that add up to 8. We had 8 up here originally. We chopped them in half to 4 and 4. So now we have 6 times 4 plus 4. Okay, you with me so far? And since we chopped them and made the 8 into 4 and 4, what are our new multiplication sentences for our new smaller arrays? Well, we have 6 rows of 4 and 6 rows of 4. Okay, notice these are just the sentences from my array. Now we'll solve for each one, which we've already done. 6 times 4 is 24, so we're going to add up 24 plus 24. Let's do that over to the side. Although you could also chunk it and say 20 plus 20 is 40, and 4 plus 4 is 8, but we're going to do it this way. So 48. So that tells me that 6 times 8 equals 48. So when you put these two smaller arrays back together to make that original large array, it totals 48. So 6 rows of 8, or 6 times 8 equals 48. Okay. All right, keep going. All right, write one way to break apart the array, then find the product. Okay, again, like I said, there's multiple ways that you can break apart arrays. So you may be thinking of something different than what I'm thinking of, okay? But we're just going to go with what examples I have for you because I can't read your minds. So here we go. First thing I'm going to do is figure out what array I'm working with in the first place. So I have 1, 2, 3, 4, 5 rows. And I have 1, 2, 3, 4, 5, 6, 7, 8 in each row. All right, we just did something with 8. I mean, you could break apart the 5 if you wanted to. But 5 is an easy skip counting number, so I'm not sure why you would want to mess with the 5. Well, how about we chop the 8? Okay. Now we could chop the 8 into 5 and 3. We could do 4 and 4. We could do 2 and 6. Because all those numbers add up to equal 8. We just did 4 and 4, right? Because they were friendly numbers. But here we have 5 rows, so we're going to be counting by 5s no matter what. So let's do some different numbers than 4 and 4 to try something different. How about, let's chop it so that our new array, I'm going to turn that into a plus sign, is 5 rows of 3 and 5 rows of 1, 2, 3, 4, 5, because 3 plus 5 equals 8. I just want to show you a different way to break apart 8. Okay. Are you ready? So our original problem was 5 times 8. Okay? But instead, we are going to be solving with 5 times 3 plus 5, because that's what we broke our 8 into, correct? Okay. And then your next step, I'm going to switch colors so you don't get confused, would be, I'm going to write it across. For some reason, they only give you 2 lines. I don't know why. That turns into 5 times 3 plus 5 times 5. Because this problem goes with my first array, this problem goes with my second array. Now, what is 5 times 3? Well, I can skip count by 5s. 5, 10, 15. So I know I'm adding up 15 plus 5 times 5, 5, 10, 15, 20, 25. I'm adding up 15 plus 25. Well, what's 25 plus 10? 35. Good. Plus 5, 40. So we know that 5 times 8 equals 40. Okay? Look at this one. Our original numbers are 4 rows of 1, 2, 3, 4, 5, 6, 7. 7 is not a friendly number. So let's think of the add-ins that go into 7. Let's think. 3 plus 4, 5 plus 2, 6 plus 1. Okay, when you think about those add-ins, which of those sound the most friendly, meaning the most likely to be able to count in your head? If you're thinking what I'm thinking, you thought 5 and 2. That's what I'm thinking, because I can skip count 5 and 2s. Let's do 5 and 2. So 1, 2, 3, 4, 5. So draw a line so that now you instead have 4 rows of 5 and 4 rows of 2. 5 plus 2 equals 7. Okay. So my new arrays that I'm solving for are 4 times 5 plus 4 times 2. Okay, I'm going to write a little less this time, so hopefully it's easier to follow. 4 times 5, 5, 5, 10, 15, 20. Okay. 4 times 2, 2, 4, 6, 8. 20 plus 8 is 28. So then I will say my original problem, which is 4 times 7 equals 28. I think that's a little neater to understand than all of that. Okay? All right, now I'm going to switch to some paper. And we're going to just practice doing some problems without arrays. You are always welcome to draw arrays to help you solve difficult problems, 100%. However, I want to also show you the steps so that you know how to break them down and how to write them, because you won't always have those arrays right there. So let's say that you have the problem of 4 times 9. Okay? And you're asked to show the distributive property to solve your problem. First thing you're going to do is break apart a number. Now, you could break apart the 9 because it is the largest number. And 9 would break apart into 7 and 2, 5 and 4, 6 and 3, 8 and 1. But what if you broke apart the 4? If you broke apart the 4 into 2s, then you could skip count by 2s. So it's totally up to you. And we can do it both ways. But let's break apart the 4 this first time. And then I'll show you it again by breaking apart the 9. So I can break the 4 apart into 2 plus 2. 2 plus 2 times 9. So notice the only thing I changed is the 4 is now 2 plus 2. And I have parentheses because they are by themselves. Now I'm going to distribute this 9. I'm going to share it equally with these two numbers. And I'm going to say, okay, well, instead of 4 times 9, now I have 2 times 9 plus 2 times 9. So we've made two smaller problems to help us solve this big problem. 2 times 9. Well, 2's are doubles. So what's 9 plus 9? 18 plus 18. Since we use the same number because they're doubles, then we don't have to solve two problems. So I'm going to go off to the side and add up 18 and 18. I get 36. So that means that 4 times 9 equals 36. Now let's do it a different way. Let's say we have 4 times 9, and you want to break apart the 9. So we can break apart the 9 in 4 and 5. So instead we'll have 4 times 4 plus 5, because 4 plus 5 equals 9. Now we're going to distribute. We're going to share this 4 with both of them. So instead of 4 times 9, we now have 4 times 4 plus 4 times 5. Two smaller problems to find the big one. So 4 times 4, well, 2 times 4 would be 4 plus 4, which is 8. And then you double that. 8 plus 8 is 16. 4 times 5. So 2 times 5 is 10. Double that, and it's 20. Remember, we learned this in lesson 1 of this chapter. 16 plus 20 is a mental math problem because 10 plus 20 is 30, plus 6 more is 36. So again, you're going to get the same answer if you do it right, no matter how you break apart or which number you break apart. Okay? All right, go grab a piece of paper or a whiteboard. I'm going to have you try some problems. Okay. I'm going to write a problem down. I want you to try it. 5 times 6. Write that down. Now, I want you to take 6 because it's the bigger number and it's the one that you can't skip count as easily. And I want you to break the 6 apart. So you're going to ask yourself, what are numbers that go into 6? Have you thought of 2 numbers? There's 5 and 1, there's 3 and 3, there's 4 and 2. Like I told you before, if you can do doubles, that's going to be less work on your part because then you only have to solve one and then double it. So what's the double that goes into 6? Okay, so now I want you to write 5 times, and then I want you to write the double add-ins that go into 6. No, I'm not writing them down yet because I want you to try. Okay, now that you did that, you're going to distribute. You're going to take this 5 and multiply it by each of these. So this is where you show your 2 smaller arrays that you've made. So now instead you're going to have 5 times blank plus 5 times, blank. So you make sure you're filling in these blanks. That's your job. Now that you have that, then you should solve for each parentheses, which they should be the same if you did doubles. And that means you have this answer plus this answer. And the total, once you add it up, will give me the answer to 5 times 6. Go ahead and finish solving that, and then I will solve it so you can check your work. Okay, let's go back and check your work. I asked you to break the 6 apart into the doubles, which would be 3 plus 3. And then your problem should be 5 times 3 plus 5 times 3. You should have solved for each parentheses, which is 5, 10, 15. And they're both the same, so then you're going to be adding 15 plus 15. And when you added those up, you should have got 30. Okay, if you got that one correct, give yourself a big pat on the back. Let's do one more. Let's say that I have 2. You're probably going to say, oh, 2s are easy. Okay, bear with me. Pretend you don't know your 2s for a moment. 2 times 11. I have an array that's 2 times 11, and I want it to be in 2 more simple problems. So I want you to break apart the big number, the 11, into 2 numbers and solve. Go ahead. I will wait, and then I will solve. Make sure you do all the steps that we've been doing. right, if you need more time, go ahead and pause the video. If not, then let's jump into it. I'm going to break it apart one way, and then I'll do it another way, and hopefully I hit the 2 ways that you did. So, you should have broke your 11 apart, so your problem on the next line should have said 2 times, and then whatever numbers you broke it apart. For 11, I'm going to go ahead and break it apart using, so many choices. Let's do 5 and 6, because 5 plus 6 equals 11, right? Okay. If you didn't do 5 plus 6, hang tight. I'll do some other choices in a minute. So then you should have written 2 times 5 plus 2 times 6. And you could have done it the other way. You could have said 6 plus 5, and then you would have had 2 times 6 and 2 times 5. You're going to get the same answer. 2 times 5, well, I'm doubling it, so 5 plus 5 is 10. 6 plus 6 is 12. 10 plus 12 is 22. So that means 2 times 11 equals 22. Let's try it a different way. If you have 2 times 11, you could have broken it apart and said 9 plus 2, or 2 plus 9. And then you could have said 2 times 9 plus 2 times 2. 2 times 9, 9 plus 9 is 18. Plus 2 times 2, 2, 4. 18 plus 4 is 22. So 2 times 11 equals 22. Let's do it another way. There's lots of ways. The bigger the number, the more ways you can break it apart. Let's say you did 3 and 8. Oops. Look at that. I'm already messing up. 2 times 3 plus 8. And then you would have 2 times 3 plus 2 times 8. 3 plus 3 is 6. 8 plus 8 is 16. You still get the answer of 22. Well, wait, there's more. Watch this. I wonder if I have any smarty pants in the group that did this one. Did anybody do 1 plus 10 or 10 plus 1? So then you would have only had to solve 2 times 1 plus 2 times 10. And you know that's 2, and that's 20. So it would have been really super simple. So there's even more ways. You can do 7 plus 4. There's a lot of ways. So you could keep going, but I'm hoping I nailed everybody's way that they picked. And I hope you have a better understanding of the distributed property. I just want you to remember that all you're doing is taking a big problem, or a big array, if you want to think of it like that, breaking it into 2 smaller problems or 2 smaller arrays, solving for each one, and then adding them back together. That's all you're doing. Have fun practicing.